See what that does for us. Okay. So we went over these a little bit in lecture, and we're just going to kind of try to drive them home again and then set up question number 4 on your lab assignment. We're going to get on the NRCS's web soil survey. Okay. And what that does is they pretty well map the soil type of all ag land in the U.S. Okay. And they have an estimated yearly forage mass production based off soil type and region, and they break that down, for rangelands. You can look at Bermuda grass and everything, but we're going to focus on the rangeland aspect. They have for a favorable year, normal year, and then a poor year. So good rainfall, average rainfall, and then drought year, and it'll tell you how much forage gets produced per acre per year. Okay, so we'll use that for some of our grazing calculations for number 4. You're going to go into this web soil survey and you're going to choose a location that's unique to you. Okay, that can be Brazos County because you live here. That can be a farm back home. It can be your grandpa's. I don't care, but I'm just going to ask, why did you choose this location? Okay, does that make sense? Cool. All right. I want you guys from the material covered today to be able to calculate stocking rate and density, understand and be able to calculate animal units, animal unit days, animal unit months. Okay. Know how to calculate the number of animals that a given area can support if you're provided with forage mass, harvesting efficiency, and then like animal body weight, and then like total number of acres. And then be able to calculate the number of days that an area can be grazed if given forage mass, harvesting efficiency, and then pasture area. All right, so just to refresh, key distinction here, stocking rate has an animal, land, and time element. Stocking density has just an instantaneous animal to land area ratio, right? So know the difference between those two. Okay. Harvesting efficiency, so that's the percent of the standing above ground forage mass that is actually consumed by the animal. Okay, this is going to be largely driven by stocking density, as we looked at in that last lecture. Okay, forage type of animal. Younger animals can graze closer to the ground than older animals. Sheep can graze closer to the ground than cows, right? Okay. But this number, this harvesting efficiency, ranges pretty widely between 15 and 90%. Okay, seen this figure before, but it just kind of paints the picture of the 100% of forage that's available above ground. Okay, what percent that is going to be consumed by the livestock? So that's harvesting efficiency. What percent is going to be just lost to the environment, either through trampling, wildlife eating it, insects, and then what percent are you going to leave, so your residual forage height, forage mass, after grazing to support plant behavior. So if you add harvesting efficiency with that other 25% that's just lost to whatever, okay, so that 50% in this image would be the defoliation rate. Okay, so harvesting efficiency, what's actually consumed, and there's going to be a portion of that that's not actually consumed by the animal, but it's lost to the environment. They stepped on it, leaf shattered, wildlife contaminated, insects came. Okay, those two added together is defoliation rate. Okay, so we want to typically graze half, so defoliate half of the plant. We want to leave half. If we can do that, then the roots of that plant never stop growing. If we start defoliating more than 50% of our grass species, okay, that plant doesn't have enough leaf area index to effectively utilize solar radiation to produce above ground forage mass to grow. Okay, so to jumpstart that leaf, okay, it's got to use the energy stored and its roots to provide the initial leaf material above ground so it has enough leaf area index to absorb solar radiation and start photosynthesizing. Does that make sense? So if we leave 50% ungrazed, so 50% target residual, okay, the roots never stop growing. If we use 70% of that plant, so we only leave 30% left, the roots will stop growing. 50% of the roots stop growing for 17 days. If we have a really high grazing pressure, we make these cattle eat these plants a lot, and we leave 10% residual, 100%, so all the roots will stop growing for 17 days. So if we make plants start utilizing those root stores, it's really going to make them less, it's going to decrease the longevity that plant is going to be in that pasture. Okay. So if we have really intense grazing and we have really high utilization rates, okay, we may have to resow our perennial species more frequently. So that costs extra money. Okay. Also bad for soil quality, soil health, right? We need good root and plant cover on soil to stop erosion, increase water holding capacity, increase soil organic carbon, all these sustainability metrics around soil. Questions? Okay. For this class, said all that stuff. For this class, I really just want you to know harvesting efficiency, what that animal's consuming. Then that's another key distinction between that defoliation rate. Okay. Not 100% of the defoliated plant is going to be consumed. Okay. And then residual forage mass. So what we have after a grazing event. Make sense? Okay. Seen this table before. So this shows the maximum utilization rate, so defoliation rate, for a number of different forage species. So the maximum that we can defoliate from a given plant is going to depend on the species of plant. Okay. Some plants can handle being grazed more intensely than others. Okay. Typically, perennial forages need a higher residual forage mass than annuals. Because do we necessarily care if that annual maintains root mass so that it can grow again the next year? Not really, right? Because it's going to, since it's not perennial, it's not going to regrow everything. It's going to be sown again each year. Typically, legumes can handle being defoliated more than grasses. Typically, okay. And also introduced species, so improved forage species like our Bermuda grasses, can handle being grazed harder than our native species. Yes.
Why is that?
That's a great question. Honestly, I don't know physiologically what makes those plants so hardy to be overgrazed. But like Bermuda grass is native to Africa. One of their main weed control strategies is to overgraze Bermuda grass swords because they'll handle it. These annual forbs don't do so well with it, right? I don't exactly know why. Okay. I'm sure we do know. I don't. Any other questions? Okay. All right. So we talked about animal units before, but one animal unit is represented by a 1,000-pound cow, typically with a calf up to 6 months of age. Okay. So an animal unit is body weight times 0.001, or body weight divided by 1,000. So if we have a 650-pound feeder animal, what's its animal unit equivalent? 650 pounds divided by 1,000, 0.65. Okay. So you can make all the calculations you need without animal units, okay, without going into animals. You don't have to use animal units to make these calculations. However, as we'll see, it can help skip a few steps. Okay. Also, NRCS, or excuse me, the Bureau of Land Management, when they make their when they charge people, it is based off of an animal unit month basis. Okay. So BLM in 2024 was charging a producer that's grazing federal grasslands $1.35 per animal unit month. Okay. So if we know an animal unit month is 780 pounds, okay, then that is $0.002 per pound of grazed forage. Okay. So how did I get 780 pounds of forage as an animal unit month? You guys remember from our last lecture? Okay. So we assume that a 1,000 pound cow is going to consume 2.6% of its body weight in a day, right? So one animal unit in a day is going to eat 26 pounds of forage dry matter. Okay? So one animal unit a day, AUD, is equal to 26 pounds of forage dry matter. That makes sense? So 26 times 30, because I realize that not every day has, or every month has 30 days in a year, or, wow, I messed that up. Not every month has 30 days, but we do that for simplicity's sake. So 26 times 30 is 780. So you can also do that same thing to calculate an animal unit year, right? 26 times 365, which I don't know what that is. I guess it'd be 9,490. Annual forage intake in pounds for beef cow, 1,000 pounds, 9,490. Okay. Any questions? Does this all make sense? Anybody getting confused or lost? Do I need to explain anything again? Okay. I think I hit all that. So if we have a 1,300 pound cow, that is 1.3 animal units. We're going to graze that for 30 days. How many animal unit days will that be? 1.3 times 30, right? 39 animal unit days. That one cow for a month is 30, what did I say? 39 animal unit days. Okay. That one cow for a month is 1.3 animal unit months. That makes sense? Everybody follow? Okay. All right. So we just talked about this. An animal unit day is how many pounds of forage one animal unit will consume in a day. So we assume this to be 2.6% of body weight or 26 pounds. Okay. So an animal unit month is how many pounds of forage will one animal unit eat. So 26 times 30 is 780. So an animal unit year, 26 times 365. An animal unit over 1 year will eat 9,490 pounds. Okay. All right. Here we're going to start going through some examples. Okay. Here we have 200 stalkers. They weigh 750 pounds. So that is 0.75 animal unit equivalents. Okay. We plan to graze them for 5 months. So 150 days. Okay. We're stalking these animals at 300 acres. Okay. So we calculate our stalking rate. So 300 divided by 200 times 0.75 times 5, our stocking rate is 0.4 acres per animal unit month. We could go animal unit month per acre, just the inverse of that, right? Okay. We wanted to express that in animal unit days. So 200 times 0.75 times 150 days divided by 300, that would be 75 animal unit days per acre. Does that make sense? Okay. Total animal units, 200 head times 750 pounds times 0.001, or we can divide that by 1,000. Our total animal units is 150. Total animal unit months, 150 times 5, 750 animal unit months. Total animal unit days, 150 times 150, 22,500. Okay, so how much forage would we need per acre to support the system? Okay, we know that we have 22,500 total animal unit days. One animal unit day is going to consume 26 pounds of forage. So 22,500 times 26 would tell us how many total pounds of edible forage we need to provide these animals. Divide that by 300, there's 300 acres. So we would need 1,950 pounds of grazable forage per acre. Now remember, we have to apply our harvesting efficiency there. So if we assume a 35% harvesting efficiency, 1,950 divided by 0.35 is 5,571 pounds of forage dry matter per acre. That's above ground. Did everybody follow that? Does that make sense? Yes.
Is the harvesting efficiency going to change?
Yep. Yep. And I think in problem 4, I make you give me one. Make it reasonable.
What's the range?
I would say 25 to 60. Okay. Any questions? Cool. Have you guys ever heard of these things before? Ever talked about animal units? Calculations for grazing? This type of stuff? Okay. I like to ask because I don't want to be too repetitive. Okay. So here's another example. Let's look at a wheat with no graze up. Okay. Here we have 100 stalkers. They weigh 500 pounds. Let's assume they're going to gain 3 pounds per day, which is a little high. We're going to graze them from November 29th to February 14th. So that is 77 days. So 77 divided by 30, that's 2.6 months, right? Our final body weight, so 3 times 77 plus our initial body weight. So our final body weight is 731 pounds. So over that 77-day period, gaining 3 pounds a day, that animal gained 231 pounds. So now we can calculate our average body weight, 731 plus 500 divided by 2. So over the grazing period, that animal weighed, on average, 615 pounds. Okay? Everybody following today? Cool. So we're stocking these cattle on 100 acres. So we can calculate stocking rate as head per acre for grazing season, right? You have to have that time element. So that would be a 1-to-1, right? That'd be a stocking rate of 1 head per acre per grazing season. Okay, but we can also do that in acres per animal unit months. Okay, how could we do that? With the information I gave you, we have 2.6 months. How many total animal unit equivalents do we have? We're going to use average body weight. 0.615. Okay. We have 100 stalkers. Okay, so 100 times 0.615 is 615. 61.5. 61.5. Okay. So 100 stalkers times our animal unit equivalents at 0.615. They're going to be grazed for 2.6 months. Okay, so 100 times 0.615 times 2.6 is what? What's that? 163. Oh, you go to total or talking rate? Okay. So acres, okay, so our total animal unit months is 2.6 times 100 times 0.615. So 61.5 times 2.6 is like 130 something, 159. Okay, so 100 divided by 159 is what? I'm guessing it's what you said, 0.63. Okay, you not get that?
Oh, it's 0.625.
Oh, okay.
Just round, yeah, that's what I said.
Yeah. Cool. All right, we can do that same calculation for animal unit days per acre. Okay. So 77 days times 61.5. 77 times 0.615 or 61.5. Okay, 4,735.5. Divide that by 100. Is what? 47.35. Okay. Our total animal unit months or animal units that we have here. So 100, that's 61.5, right? Total animal unit months. I think we already did that to get to our stocking rate. Total animal unit days. What's our total animal unit days here?
We said 135.
Okay, 4,735 times 26. That's 26 pounds per animal unit day. Divided by 100, you get it per acre.
1,231.
Okay, so that is grazable. Okay, so this is wheat pasture. It's an annual forage. I'm going to assume that we can graze it a little harder. Okay, so take that, divide that by 0.75. So we need 1,641 pounds of above ground forage mass. Okay, I think I've got this all worked out here. Well, of course, I switched from 75 to 50, so that doesn't make any sense. But if you ignore my mix up on the slide, it looks like we had all that. Does that look right, you guys? Yeah. Except here, at the previous slide is 0.75, harvesting efficiency here at 50. I don't know what I did. Okay. Is this not making sense to anyone? Okay. All right. So if the wheat pasture needs basically 2,500 pounds of above ground forage mass, and then we recommend 5 pounds of forage dry matter per pound of body weight, so that's our forage allowance, on average across the whole grazing period. Just as a rule of thumb, that's our target, or that's our critical forage allowance for wheat pasture. Okay. We would need 2,500 pounds of forage per acre for a 500 pound calf. Okay, if we have it stocked at 1 steer per acre, or 1,250 pounds of forage per acre for a 500 pound calf if we're stocked at 2 acres per steer. Okay, So how can we make this work in a grazing system? Okay, when our target forage amount of 1250 with 2 acres per steer is below what we just calculated we need our above ground forage mass to be. Does it make sense what I'm asking here? Okay, what are we not considering when we're basing our stocking rates off of forage allowance? So that forage is going to be grow while the animals are still out there. Okay. So a good rule of thumb is that small grains, so winter annual pastures, will grow 3.5 pounds of forage dry matter per acre per growing degree day. We talked about this in our last lecture. A growing degree day is calculated as average daily temperature minus that plant's critical temperature. Okay. Wheat and typically our small grain annuals, winter annuals, we will assume their critical temperature to be 32 degrees Fahrenheit. For warm season grasses, it's typically 50 degrees Fahrenheit. So if we know that, we can get a good estimate on what our forage growth over that grazing period could be. Okay. So went to Oklahoma. They've got, I spelled mesonet wrong. Well, actually, no. I need a space between mesonet and at the bottom here. So in Oklahoma, and I think they also have it in Texas, there is a kind of company, I think it's public, weather company that a lot of people use for ag, but they have a lot of different monitoring sites. So they collect temperature data, rainfall, wind speed, so all our weather related data. So I went to Stillwater, Oklahoma, okay, from November 29th to February 14th. So that'll be about when we would have cattle would have been grazed in that area. And I pulled out the average ambient temperature from that. Okay, with that, I calculated the growing degree days for each day of this hypothetical grazing system period. Okay, and so that's what this figure is shown on the left. Okay, so that's forage growth in kilograms per hectare, which is basically pound per acre, because there's 2.205 pounds per kilogram. There's 2.47 acres per hectare. Okay. So you can see they're kind of early fall. Typically, you have periods where grass will be growing. Middle of winter, ambient temperature can be below the growing degree days, so you expect negligible growth there as it starts warming back up in late winter, early spring. We're going to expect forage to start growing again. Okay, so this on the right would show cumulative forage growth over this hypothetical grazing season. Okay, so within this bracket, we have 25.5 pounds of dry matter growing per acre per day. There in the middle is negligible. There's next to no forage growth. And there at the end, we have 35.5 pounds per day. Okay. Why would we expect spring growth rates to be higher than winter or late fall? Spring flush. So this kind of hypothetical situation matches. So over the total growing season of this model wheat pasture system, 1,313 pounds per acre, pounds of forage was grown per acre. Okay. Okay. Now I kind of added cattle to that hypothetical scenario. Okay. So the left is now standing forage mass in pounds per acre. Okay, that's our y-axis. Okay. There where we had real fast growth rates, Okay, and so this accounts for dry matter intake, assuming 2.6% of their body weight these cattle would consume. Okay. Each day I added 3 pounds to their body weight to account for these animals are growing. Okay. I assume that turnout we would have 2,500 pounds of forage dry matter per acre as our initial forage mass. Then I added the calculated forage production and then subtracted daily intake. Does everybody follow this hypothetical simulated grazing system? Okay. So in the period early from late November to what would that be? Late December, when forage mass was growing, right, it was actually accumulating. We actually saw an increase in standing forage mass. Okay. However, when there's no growth rate, those animals are going to start depleting forage mass because consumed forage is going to be greater than forage accumulated, grown forage, right? So that late January, we are down to 2,300 pounds of forage per acre. Okay. Then after that, we start going through this period again where we have forage growth again. Okay. So that by the end of the grazing season, we have close to the same amount of forage mass that we started with. Okay. Does that make sense? Yeah. This whole hypothetical situation is just so that you guys can understand that we calculate, we make these calculations based on how much forage is currently there. Okay. We want to have close to a stocking rate that will kind of maintain above ground forage mass. Okay. But really we need to account for forage that's being produced while the grazing season is going on. Does this make sense? Okay. All right. So these are some examples. You will get questions just like this for your exam too. Okay. All right. So for this scenario, we have number of steers, 200, the weight of the steers, 650. Assume that they're going to eat 2.6% of their body weight. Okay. This grazing system has 340 acres. Our target defoliation rate is 50%. Okay. Don't use that when you're calculating how much above ground forage mass you actually need. Okay. That's in there as a red herring. A lot of people use that last year. What you really want to use is this harvesting efficiency. Okay. So that's 25%. Forage mass, pounds per acre, is 5,500 pounds of forage dry matter per acre. Okay. So if we know forage mass per acre and we know number of acres, we can calculate total above ground forage that this system has. Okay. So 5,500 times 340, like 1.87 million. Okay. Now we need to calculate how much of this is actually available to graze. So how would I do that? Okay. What do we get?
467,000.
Sorry, what's that?
467,500.
Okay. Okay, we need to know how much total dry matter intake these animals are having. So 650 times 0.026, they're eating 2.6% of their body weight. 16.9. So on average, they're going to eat 16.9 pounds of forage per day. Okay. If we know how many pounds is actually available for that animal to eat, divide that by 16.9. We can calculate how many days we can graze these cattle in the system. Anybody have that? 16.9 times 200 head. 138? That seems reasonable. Okay. So what is our stocking rate in acres per head per grazing period? So we have 340 acres. We have 200 head. 340 divided by 200. Okay. Our stocking rate in animal unit days per acre. Okay.
$52.7.
52, that sounds reasonable. Okay. Our forage allowance. Now, forage allowance is calculated as total above ground forage mass. Okay, not actual consumed forage. So I walked you through that last year. So it's 5,500 times 340 divided by 650 times 200. So pounds of above ground forage mass divided by total pounds of animal body weight. Sounds reasonable. Okay. So that just shows you the math off to the side there. I think we got all that. That all looks right to me. Okay. Okay. So if we did this on a, you can make these calculations a different way, right? So there we really didn't use animal unit days except for that second way we counted or calculated stocking rate, animal unit days per acre. Okay. So now if we know total forage mass, that's grazable, so 467,500. We can divide that by 26, because one animal unit day is going to consume 26 pounds of forage, right? So we can support 17,980 animal unit days in the system. Okay. So 17,980 divided by 340, which is how many acres? That'd be, we can support 52.88 animal unit days per acre. Okay. And then 17,980 divided by 0.65 times 200. So 0.65 is our animal unit equivalents times 200. We're grazing 200 head. So just with the total amount of animal unit days that's available to graze divided by how many animal unit equivalents we have will tell us how many days we can graze this system. Does that make sense? So you can make these calculations without using animal unit days. You can make these calculations with animal unit days. If you do it with animal unit days, you can skip a few steps. Make sense? But be able to do it both ways so that if I ask you on the test, you can do it. Okay. So whenever you're doing these math problems on the test, be very careful and like hyper focus on what units I'm asking for. Okay. Okay. So here's another scenario. You guys want to work through this? I'll let you guys do this real fast. The answers are on the next slide, but maybe try your hand at it first before you peek ahead. Anybody having problems? Anybody still working on it? Everybody done? No? Anybody have any questions? What's that?
How did you get forage allowance?
Huh?
How'd you get forage allowance? Cause I keep getting 13.52.
Okay, 1,504 times 225 divided by 500 times 50. Do I have the wrong number over there?
It says on here 3.3. So
Oh, no. Is that number wrong? I think that must be, is it supposed to be 13.38?
13.54.
Okay. Yeah, I don't know. I'm not infallible. Okay. Good question. Any other questions? Okay. I'll try to remember to go back and fix that. No promises though. Any other questions? Everybody got it? Okay. Be ready to do these types of things next week on Monday. You have to do it for your lab assignment. Okay. Be set up just like this table with missing data. You have to fill out. Okay. Pay close attention to units. I could flip them. There's no standard order of animal component, plant component, time component, or anything like that for stocking rate. So I could ask you acres per head, acres per animal unit day, animal unit days per acre, so on and so forth. Okay. All right. So, like I said, we're gonna play around with the web soil survey on the NRCS website for this homework. Okay. So I tried to do better this year at walking you through on your actual assignment on Canvas with screen grabs and highlighting what boxes to click and things like that. So I'm hoping we don't have as many issues with web soil survey this year as we did last year. Okay? But it's kind of cool because it could allow you to go back and look at your home place and see what the NRCS says that your forage match should be, and then calculate your stocking rate for a good year, normal year, bad year. Okay. So think about what class of animals you want to use. If you back home use cows, hell, I don't care, even though this is stocker feedlot, you can use cows. That's fine. Yeah. But do you want to know why you guys chose what you did? Because it's kind of cool when someone can say, this is the place I grew up or whatever. But if you don't have something like that, and you just want to pick something that's close to here, that's cool too. Okay. Okay. All right. So follow this link. That should take you here. Okay. So you click Start WSS Web Soil Survey. It'll take you here. So this is a map of the contiguous US. That makes sense? Okay. So under this tab here, under Area of Interest, I can go here, State and County. Well, we want to go to this one. So Soil Survey Area. So this is where we're going to set our AOI, our Area of Interest. Okay. So I think in the notes I say, let's go to Oklahoma. Okay, and I think I say Osage County. And I click Set AOI. Okay. So this map's a little funky. To zoom in, I click here, and then I can go drag it on the map. Okay. To go around, you click on that, and then it'll click you and let you drag. Does that make sense? You can't drag and zoom around the map whenever you have, well, you can't drag when you're select that you're going to zoom, right? So if you try to drag when you're, if you drag when you're set to zoom, you're going to have a bad time. Anybody remember that from South Park? No? Okay. All right. Okay, so now I've set my area of interest. I can come here to Soil Data Explorer. Okay. And I can go to Vegetative Productivity. I can come down here to rangeland production favorable year, normal year, or unfavorable year. So let's just start there. So if you want to view description and it'll tell you what is a, like, I don't know, what is a rangeland. So this box will come up here. what does that say? Range of land production, total range production is the amount of vegetation that can be expected to grow annually in a well-managed area. And just kind of describes what this metric is, okay? Everybody following? Okay, I can click here to view rating. And for each soil type within this county, so each of these rows is a soil type. So this is map unit symbol 6, but this is the type of soil it is. Catoosa, Schilder, Lula complex, and then it's at 1 to 3% slopes. Okay. Then here it'll tell you what the rating is, and so this is pounds of forage dry matter per acre per year. Okay. Now this tells you what percent of the area of interest each soil type represents. Okay. So whenever you come through and you're pulling this information out, and I ask you, why did you choose that soil type? Okay. One simple justification could be it's representing the largest percent of the AOI, the area of interest. Okay. Another justification could be, for example, this soil type is the most characterized of my farm. Okay. I don't necessarily care, but I think I asked you to take a screen grab of the table that shows this forage mass. Okay. So, we're going to look at wall code, the white complex soil type, 0 to 3% slopes. There we go. That's item 69. So this forage on a favorable year should produce 4,795 pounds of forage per acre. Okay. So one thing you can do, let's say your farm back home is right here. You can zoom in, and then you can actually read these codes. So like anything that is, or this yellow here where this cross is, right, is item 62. Okay, so if you look at the map and you say, wow, my soil type is mainly at my back home place is mainly item 62, you can come down here, find item 62, and you're producing 3,961 pounds of forage per year on a favorable year. Okay. So you can do the same thing, or you're going to do the same thing for a normal year, then an unfavorable year. Okay. I don't remember if I give you the number of acres or if I let you specify it. I don't remember if I give you the classic cattle or if I let you specify it. Does that make sense? I do think I give you the percent of body weight that we're going to say these cattle are eating. And I don't remember if I give you the number of days or not. Okay, it'll outline all that in the problem. Okay, so just whenever you're compiling this into your Word document, you're attaching your screen grabs, and you're justifying the decisions you made. Okay, just kind of, I guess, keep track of that. Any questions? Is there anything someone wants to see? Now, I also don't know if every single county has range production favorable year. I would say the vast majority or all of them that I've kind of explored, looked at, do that. Okay. But if you chose a county and for whatever reason you can't find range production, favorable year, normal year, unfavorable year, may just have to choose another county. Okay. Questions? Okay.
Crossroad activity.
Where's this? I don't know. Let's find out. View description. What does that say? Can you read it? Relative ranking of soils based on their potential for intensive crop production. Ratings range from 0, which I guess is unfavorable, to 100, which is very favorable. Not crop specific. Okay. I don't know how important that should be. Good question. Oh, the other thing we'll look at. So you can go down here to yields of non-irrigated crops. Then I can click down here and let's just choose introduce Bermuda grass and then view rating. Okay. So they won't let you do it on a good year, bad year, normal year, right? But it does give you a rating for Bermuda grass at each of these soil types. But that rating there, 6.21, is how many animal unit months. So you can take 6.21, multiply by 780, and that'll tell you yearly forage mass. Does that make sense? So you can use this to estimate forage production, even just non-rangeland species. Okay. See if there's anything else I'm supposed to say. Okay, so here, this is an example of the problem that scenario I came up with. So we have a half section of grazable land. How many steers can a 650-pound average body weights can we graze for 150 days? For a favorable year, favorable, normal, or unfavorable year, we're going to assume a 25% harvesting efficiency and assume 2.6% of body weight intake. Okay, so for a favorable year, we can stock them at 2.12. Normal year, we'd need 2.9 acres per steer. Unfavorable year, 4.3. Everybody follow that? Any questions? If you have problems and you need help, come find me. Okay, or Kyle, maybe preferably Kyle. Okay. You guys can go.